afternoon, dear team. So today we are going to discuss a chapter, chemical bonding. So first of all, the intro part of chemical bonding is matter is made up of one or more different kind of elements that exist independently under normal condition. All the atoms in the periodic table exist in the form of combined state except noble gases. Noble gases like helium, neon, argon, krypton, xenon. So all other atoms are, why they are combining, why they are existing in the combined state? Only because of the two reasons. First one is due to the stability, and second one is Lewis octet rule. To complete their octet configuration, they are combining. So the first question is why they are combining. Next, what is the chemical bond? The attractive force that holds two or more atoms in a combined state, that is known as a chemical bond. Molecules, or we can say the atoms are in the aggregate form, or they are exist like a single entirety. We can say in a chemical bond there is just a redistribution of electron. Further we will discuss the types of chemical bond: ionic bond or a covalent bond. Firstly we will discuss what's the attraction, what's the repulsion, and overall in the chemical bond attractive forces are there or repulsive forces are there. If I am taking an example of hydrogen molecule, there are two hydrogen atoms. In one hydrogen atom, one proton and one electron is there. Other for the same hydrogen atom, there is one proton and one electron is there. And as we know all, there is an attraction between the dissimilar. Means for a proton and electron there is an attraction between them, and for a proton and proton there is a repulsion between them. If overall there is a attractive forces between them, then we can say there is a formation of a chemical bond. So here we have a new attraction between the proton and other atom of hydrogen and proton of other atom of electron of hydrogen atom. So we can say that there is a total attractive forces between them, so there will be a chemical bond formation. Next, there are examples. First of all, everything in the universe wants to stable. Same for the atoms. Why? If I am taking an example of red hot iron, it is hot. After some time, what will happen? It will release energy, or we can say that radiate energy. It becomes cooler down slowly and become cool. So we can say that red hot iron after some time radiate energy and become cool. Next one is stretched rubber. If I am stretching a rubber, what will happen? Potential energy is increases. So the stability decreases. If I am stretching a rubber, it expands, and if I am releasing the force, what will happen? It contracts back. Why it contracts back? Because of attaining the stability. So next is our graph, that is between the potential energy and distance, internuclear distance. From this we can say stability is inversely proportional to the potential energy or vice versa. So this is a graph between the potential energy and internuclear distance. If there are two hydrogen atoms which are present far away from each other, we can say that internuclear distance is more. And if they are combining to form a hydrogen molecule, their energy will decreases. So here we have a hydrogen molecule whose energy is low, and for the attraction it is low, and for the repulsion it has high energy. Am I clear? Yes. So from this graph we can say that energy should be, if the energy is low, then the molecule is stable, and stability is inversely proportional to the potential